Recall that the standard form for a circle is x minus h squared plus y minus k squared equal to the radius squared. So when they give you information that the center is at -5, 2, well, this is your h and this is your k, and then your radius, which is r, is 6. So basically, to put these things into the equation, we have to put the h, which looks like a -5 right now, we have to put it there. But since there's already a minus or a negative there, it's basically going to change the sign. Because if you had a minus, a -5, that's just going to become +5. So that's why when you put it in the equation, it's opposite of what it looked like it was. So instead of -5, you're going to put it in as +5 squared and then plus. So when you do the y value of the center, the k is +2, so it's going to go in looking like a -2 squared. And then your radius is 6, so when you put the radius in, notice you have to square the radius. So 6 squared is 36. So there is our equation of our circle with center -5, 2, and radius 6. So now, working kind of backwards, it gives you the equation. We'll notice there's no h and k inside of here with x and y. So very simply, our center is 0, 0, which I should have just put right here, because we have to anyway. And then the radius, remember whatever is sitting right here is the r squared. Well, if it's 24, in order to see what the radius is without the squared, you have to take the square root of that number. So if you take the square root of 24, that is approximately 4.9 if we round to the nearest tenth. And if we just left it in exact form, that square root of 24 simplifies to 2 radical 6. So if there's like a multiple choice problem and it asks for the radius, you wouldn't want to put 24 because that's the radius squared, so you have to take the square root, and it might put it as 2 radical 6. But if you were having to graph it, that would be better understood as a decimal, so you would kind of know where to go on the graph. So we're going to graph it by first starting at the origin, which is 0, 0, so making our center point. And then the decimal is definitely going to be easier to graph than it would be the exact form. So basically we're going up, down, left, and right almost 5 units. It's going to look like it's at 5 units because it's going to be right before the 5 in all directions. So right before the 5 in all directions are -5. And then remember, when you make your circle, you want to try to make it as round as possible in each section. Not, you don't want it looking like a diamond. And, ooh, that was looking a little diamondish. So there's our circle. It's the center 0, 0, radius about 4.9. So for this next one, you have to remember that the numbers that are here for h and k, they're basically looking opposite of what they really are. So really that comes out as a +2. And this is going to come out as a -3. So if you forget that part, you will basically get it wrong, because that is key to remembering that they're opposite of what it looks like they are. And then remember, this is our r squared sitting here, so you have to take the square root of that number to get what the r really is, which is 5. So now if we're plotting that, we're going over 2 and down 3 to make our center point. And then our radius is 5, so that's where we're going to go up, down, left, and right 5 units in every direction from the center. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. And then make your circle. So same process every time, just basically find the center, find your radius, and then plot those things. So for number 4, which of these do you have to use to determine if a quadrilateral is a parallelogram? Well, basically, in order to determine if it's a parallelogram, not only do you need to have congruent sides, you also have to have opposite sides parallel. So basically, you would need to know that the slopes, this is what a parallelogram looks like, one type of parallelogram, or one shape. It could be vertical this way or something like that, but either way, the slope of the opposite sides, those are equal because parallel lines have the same slope. So you'd basically need to find the slope of each side and make sure that they match. So the slope of this one matches the slope of this one, and the slope of this one matches the slope of this one. So really, it really relies on the slope, because you can determine that it's a quadrilateral. Basically, they're already establishing you have four sides. Is a parallelogram by having the same slope. You'd also need to have equal lengths, so it's kind of like you need that too, but this is the main one, because if you just had equal lengths and not parallel sides, you could have something else, a different type of shape. Alright, kind of like a kite that has same lengths, but they're not opposite sides kind of thing. But either way, parallelogram, make sure you know that the opposite slopes are the same. Alright, so when you're determining if you have parallel lines, remember that for parallel lines you have to have the same slope. So anytime you have parallel lines, you have the same slope. And remember, if all your equations are, you have an equation in y equals mx plus b form, your slope is m. So basically you're looking to see if your m's are the same. So if you look at each equation, there's 2 in each answer choice. Your slope in the first one, your m in the first one, is -3. If you notice, your slope is always next to x. So we have -3 in the first equation, +2 in the second equation, so we know it's not A. Alright, moving right along, in option B we have 3, and then we have 1/3. Those are not the same number, so that is not an option. Then for C we have 3 again, and -1/3. Those are not the same number. And then the last one we have -3 and -3, so we know that those are parallel lines. It does not matter what the B is, as long as it's not the same, really, because if it was the same, it'd be the same line. Okay, and for number 6, if we want to prove that we have a parallelogram and we want to show our evidence, well, first, there's a few things we need to make sure we do. Parallelograms, they have opposite sides congruent and opposite slopes the same. So if we find the opposite, or if basically we find all the side lengths, first we need to find that. So we have this side here, which is side AB, and the side opposite of AB is CD. So we need to first go ahead and find their lengths, and we can find their slopes. So their distances, or their lengths, you can either use the distance formula, which remember is d equals the square root of x2 minus x1 squared plus y2 minus wrong place, y1 squared. And you could either use that, remember if you use that, you basically just need to write down the coordinates for A and B, or you can go ahead and use the Pythagorean theorem, because the distance formula is just a version of the Pythagorean theorem. So if we want to go ahead and find the distances, since it's on a grid, I'm going to use the Pythagorean theorem because I can easily make the right triangle that is formed with that side. And that right triangle has side lengths 3. We count 1, 2, 3. And 1, 2, 3, 4. So basically, if I use the Pythagorean theorem, I would have 4 squared plus 3 squared equals c squared. And for this, I get 16 plus 9, which is 25, equals c squared. So therefore, I know c equals 5. So I know the length of AB is 5. Now I can do the same thing for CD. If I do my rise and my run, which creates that right triangle, I have a side length of 4 again, a side length of 3. Well, therefore I know when I put it into the Pythagorean theorem, it's going to look exactly like it did for AB. So I know the side length is going to be 5. Well, not only that, I need to do the slopes. So I need to find the slopes for A, B, and CD. So remember, you got to think rise and run for slope. Well, our rise, if we go from A to B, we would have to rise. Now you could use basically the triangle you made over here, but if you think about rise and run, you would have to go down to get to B if you started at A. So that's a -4, since now we're thinking of direction. And then going over to the right is +3, so that +3 is also fine. So our slope would be the rise, which is -4, over the run, which is 3. Another way to remember that your sign is negative for this slope is that the line goes downhill from left to right. So since side AB goes down, it's a negative slope. All right, same thing here. Our rise, yes, we rise positive 4 this time, but we run in the negative direction 3 units. So that is another 4, -3, which is the same thing as -4/3 in both cases. So that's those opposite sides. So now we also have to handle the other sides, which are AD and CB or BC. I'm going to name it BC. Alright, so we need to find those distances or those lengths. Once again, I'm going to choose to use the Pythagorean theorem since it's on a grid, and it's pretty simple and straightforward on a grid. So that's a side length of 2. And then we have 1, 2, 3, 4, 5, 6. Side length of 6. So if I use the Pythagorean theorem, I'm going to have 2 squared plus 6 squared equals c squared, which is 4 plus 36, which equals 40. So c squared equals 40. So c equals the square root of 40. And if you put that in your calculator, you get the exact form of 2 radical 10. We might as well leave it in exact form since we're not trying to graph. All right, and if we do the other one, we have a right triangle created over here, which also has 1, 2, 3, 4, 5, 6, a side length of 6 and 2. So as you notice, when we put it in Pythagorean theorem, it's going to look exactly like this too. So we know they both have the same side length. All right, now just to make sure we have a parallelogram, we also have to make sure our slopes are fine. So just like we did with AB and CD, we have to make sure our slopes for those two sides are congruent. So if I go from A to D on the graph, I'm rising 2, so that's a positive 2, and I'm running positive 6. So I'm going positive direction, and this slope is positive. So I know it's positive 2 over 6, which simplifies to 1/3. And then at the bottom there, we have it is a down. If I go from one to the other, going down 2, so that'd be a -2, and over to the left 6, so that would be a -6. But a -2 divided by a -6 is the same thing as positive 1/3, because a negative divided by a negative is a positive. So therefore, we have the same slopes. And since opposite sides have congruent slopes and opposite sides are congruent, we know we have a parallelogram. So opposite side lengths and opposite slopes are congruent. So we have a parallelogram. Alright, so that's basically, we got to make sure we know if we're looking for a parallelogram, we have to have opposite sides the same and opposite slopes the same. Alright, so now when they just ask you simply to find the length of a line segment, you can, if it's on a grid, you can use the Pythagorean theorem. If it's not on a grid and it just gives you the 2 coordinates, you could put it on a grid and use the Pythagorean theorem, or you can use the distance formula in either case as well. So since I used the Pythagorean theorem when I did this problem, I'll go ahead and use the distance formula just to kind of review that too. So if we're going to use the distance formula, well, we need the distance formula, which is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And we need the coordinates. So the coordinate for A is over 3, so our x value is 3. Our y value is 2, so that's 3, 2. And for B, the x coordinate is 5. The y value is 6. Remember, the x always comes before the y, just alphabetical order. And now we can label those as our first x value, our first y value, our second x value, and our second y value. So now we just simply substitute, and I like to erase and replace so that I know I put everything in the right place. So let me see if I could do that without erasing everything. Kind of, it looks like. Alright, so x2, if we look over here, x2 is 5, so I'm going to put 5 in the place of x2. x1 is 3, so I need to put 3 in place of x1. So we have minus 3. And then y2, so if I look over at my graph, y2 is 6. So I need to erase y2 and put 6 there. And then lastly, y1 is 2. So I'm going to erase y1 and put 2 there. Can't erase that. Alright, so now you can actually put this entire thing in the calculator and see what you get. Just make sure when you do it, the square root remains over the entire thing. Don't forget your squares, because that's often forgotten, and don't forget the plus in the middle. Use all the parentheses and etc. I'm just going to do part of this kind of like mental math so I don't have to put in so much. Because I know 5 minus 3 is 2, that's really 2 squared, plus I know 6 minus 2 is 4, so 4 squared, and then it's all under the square root. If I want to do it just a little bit more mental math so I don't have so much to put in the calculator, I know 2 squared is 4, and I know 4 squared is 16. So really it's the square root of 4 plus 16, and I know that is 20. 4 plus 16 is 20, so that's the square root of 20. So it should be the square root of 20, which doesn't simplify exactly, but if you wanted to write it as a decimal, it would be, no, actually I think, yeah, actually it does simplify. It'll simplify to 2 radical 5. So let me get rid of those approximately symbols, but then that is approximately 4.47 if I take it to the nearest hundredth place. Alright, so that is our distance. And make sure it makes sense, which is called plausible. Make sure it's plausible, because if you get something like 20, well, you should see right there, there's no way, and I'm just going to erase some of this on the graph, there's no way that line segment could be 20 units long. If you look at how long a unit is, that's how long a unit is. So if I was estimating this length across the whole thing without looking at the thingies there, I would expect it to be somewhere around 4. But obviously estimation is not good because it's really almost close to 4.5, but the point is, you know, it's not 20 of these little lengths. 20 of those little lengths would be 20 lengths in either of these directions. It's way longer than the grid. So make sure your stuff makes sense. That's half the battle on a multiple choice test or an EOC, something like that. Alright, and then also on this one we have to find the midpoint. I am going to estimate where I think it is first with just sight. So looking at this, the middle of this line I would put probably there. So I'm not going to be 100% confident in my estimation because it could be a decimal. So I'm going to make sure I just use my midpoint formula to make sure I'm on point. I still need my coordinates, so I'm going to put those back. It was 3, 2 and 5, 6. So remember the midpoint formula is just the average of the x's. So basically you add the x values together and divide by 2 and average the y's. So you add the y's together and divide by 2. And that's your midpoint formula. So if I look at my x values, they're 3 and 5. So if I average 3 and 5 together, I would get 8 over 2, which is 4. And then I need to average my y values, which are 2 and 6. So 2 plus 6 divided by 2. That is 8 again divided by 2, which is 4. So it looks like my midpoint is 4, 4. Which that is my estimation. My estimation is 4, 4. So not a decimal, it's exactly 4, 4. So number 8 is kind of basically a way of asking for the midpoint without using the word midpoint. So it says to find the center of a circle. So here's my circle. It's a terrible circle, but it says it has a diameter with endpoints at -5, 3. That's definitely a -3. So -5, 3. So it's a diameter, so I know it's the distance across the circle, and 2, 6. I'm trying to find the center of the circle, which I know is going to be the middle of the diameter. So basically I'm finding the midpoint using these coordinates. So I need to find the midpoint using those. So once again, I'm going to average my x values, -5 and +2 over 2, which is the same thing as -3 over 2, because that's what it simplifies to. And now I need to average the y values, which are 3 and 6. So 3 plus 6 divided by 2, which is 9 divided by 2. And neither of those simplify, so we're just going to leave it as negative 3/2, comma 9/2. And that is our answer for our center. Alright, to find the other endpoint, if you're given a midpoint and an endpoint, there's two methods I showed in class. One's an algebraic method and one's kind of like a number sense method. So number 9 is very similar to that. It's basically telling you you need to find the coordinates of the other endpoint. So I know I'm finding an endpoint of a diameter with an endpoint, so it gives you one endpoint and it gives you the center, so I know that's the midpoint. So basically I'm looking for the x1 that I'm adding to the x value of the endpoint and averaging. That's given me the center x value. I'm looking for that, and I'm looking for the y value. Give her that little mark. So I'm looking for the y value that when I add to the y value of the other endpoint and average it, it's going to equal the y value of the center. So I could do it that way, solve both equations, and get what my x1 and my y1 have to be. So just showing that route, I'm going to multiply both sides by 2 to get rid of that 2. And that gives me that x. I don't really need the x1 on it, so x plus negative 1 equals 4. And then I need to invert that negative 1 by adding 1 to both sides. So basically that gets rid of that, so I have x equals 5. And then to do the other side here, I multiply both sides by 2 as well. That'll get rid of that 2 at the bottom, and we just have y plus 5 equals negative 6. And then I need to subtract, oops, it's moving pages on me because I'm really low at the bottom there. Try to fit it in. Let's see if it's gonna, okay, so minus 5, we get y equals negative 11. So based on the algebraic method, it looks like our midpoint, our other endpoint is 5, negative 11. Just to show it the number sense way that I showed in class, which could be simpler. We know we're missing an endpoint. We have the midpoint, and we have another endpoint. So we know we could just put what we have next to what we have here, and it doesn't really matter where you put the endpoint we have. I'm gonna just put it at the top. We have negative 1, 5. We have our midpoint, which is the center of 2, negative 3. And the number sense way I showed is just showing, okay, if this was a number line, how would we get from negative 1 to 2 on a number line? Well, I would add 3. Well, if you add 3 again, because it has to be the same distance to the other endpoint, 2 plus 3 is 5. And as you see, we get the 5 that we got earlier when we did it algebraically. So same thing for the y values. To get from 5 to negative 3 on a number line, positive 5 to negative 3, I would have to subtract 8 to get down to negative 3. So I need to subtract 8 again, because once again the endpoints are going to be the same distance from the midpoint. So negative 3 minus 8 is negative 11. So whether you do it the number sense way or the algebraic way, you get the same answer. Alright, now for number 10, we're writing an equation that passes through the point negative 3, 4 and is parallel to this equation. Well, if we know it's parallel, we know they have the same slope, so basically the only thing that I need out of this equation is the slope, because I know it's going to be y equals negative 3x plus b, because remember our format for our equation is y equals mx plus b. And we are looking for, we already have this equation here, so that's some line on our graph. Oh, that's ugly. So some line on a graph, we have some other point that's floating out there, and we want the second line. We want to write the equation of that second line that's parallel to the first one. So that's why we have to find our own b, All we're using out of that first equation is the slope. So now, since we know this point is going to be on that second line, we need to use that as our x value and our y value inside of the equation. y equals mx plus b, so inside of this. So we know the y from that coordinate is 4 equals -3. Our x from that coordinate is -3. And then we are looking for little b. So basically if we simplify, we get 9 here. So we have 4 equals 9 plus b. And if we subtract 9 from each side to get b by itself, we have b equals -5. So we know our b is -5, we know our slope is going to be -3. So the final equation we should have is y equals -3x, and our b we just found was -5. So I'm just going to write that on the line. So y equals -3x, because notice they need to have the same slope if they're parallel, but they have different b values. Alright. So to do number 11, we're writing an equation that passes through this coordinate now. So there's our x and our y we're going to use, but perpendicular to this equation. So perpendicular, remember, that doesn't mean they have the same slope. That means they have opposite reciprocal slopes. Alright, opposite reciprocal. So basically if we look at the slope that's currently there, which is -5/2, we need to do the opposite sign. So we're going to bring it out as positive, and we're going to flip it to do the reciprocal. So +2/5. So when we do our y equals mx plus b, we're going to use +2/5 x plus b. And now we can go ahead and substitute in the coordinate. So we're going to put 5 in place of x. So we can put 5 there in parentheses. I'm going to bring down my 2/5, my plus b, and we are putting -3 in place of y. So now if we actually just simplify this part, those actually invert each other. But if you put in the calculator, you also see that is just equal to 2. And I bring everything else down, and then I add 2, nope, not add. We're going to subtract 2 to get rid of it, and subtract 2 on the other side. So we have b equals -5. So our final equation is y equals, remember to use the slope that we found after we did the opposite reciprocal, so this one here, so y equals 2/5 x minus 5. So I need a little bit more space for number 12, so I'm going to go over here. So to find the perimeter of a rectangle with these coordinates, well, one, I can grab a graph paper, which you can ask for during any test, and plot them and find the side lengths, because when we do perimeter we need to add all side lengths. Now if we don't want to grab a graph paper, we can also find the distances using the distance formula and then add the sides. So either way, since I don't have a graph paper and I don't feel like finding one on the internet really fast, I'm just going to go ahead and use the distance formula, because remember the distance formula is a version of the Pythagorean theorem. So if we are going to do this, remember it's a rectangle, so it has 4 sides. So basically I have to find the distance between all combinations. So, well, not all combinations, but if we think of this is A, this is B, this is C, and this is D, I need to find the distance AB, the distance BC, so let me write that down over here, CD, and DA. So I need to find all those distances. I don't need the diagonal distance, so that's why I said, well, not of all combinations, but so we need the 4 sides. So if I use the distance formula correctly, remember there's a lot of error that could be made if you don't put the things in the right places. If I use it correctly, though, I can get the distance for all sides, which is the side lengths. So remember the square root. So for AB is, we have x2 minus x1, so we should probably label for doing AB. This is our x1 right now, our y1, x2, our y2. So we have x2 minus x1, which is our x2 is 5, minus our x1, which is 2. So 5 minus 2 squared, plus now our y values. So y2 minus y1, which is 3 minus 6 squared. We gotta make sure our square root goes over the entire thing. Once again, you can put the entire thing in the calculator and you will get 3 radical 2. Alright, so the next one, we're doing BC. So now it's the square root of, so now I'm going to erase what I have because now we're going to have BC. So I'm going to erase this. Oops, put my B back. But we are going to do BC. So now our x1 and x2 are going to be with B and C. So x1, x2, y1, y2. So x2 is negative 3 minus x1, which is 5. So square root of negative 3 minus 5 squared plus, and then our y2, which is negative 4, minus our y1, which is 3 squared. Alright, if we put that in the calculator, we get, that's the square root of 113. It does not simplify, so we leave it like that. And then now we do CD. So for CD, I'm going to relabel. So we have x1, y1, x2, y, ooh, it's not like a y, y2. So we have the square root of our x2 minus x1. So that's a negative 6 minus a negative 3. If you do not put that minus a negative and you just put minus 3, that is going to be incorrect. So make sure you don't think that the minus in the formula is your negative, because it's not. And then plus your y2, which is negative 1, minus your y1 is negative 4. So negative 1 minus a negative 4. Alright, so if we do that, we get another 3 radical 2. Alright, so if we do our last one, which is dA, I'm going to erase our labeling so we can relabel. So dA, that's all the way here. D is x1, y1, and A is x2, y2. So we have the square root of, we have to do our x's first, so our x2. Now you could have labeled A as your x1 and y1 and vice versa, but since I labeled it this way, I'm going to use it this way. So I have 2 minus a negative 6. So 2 minus a negative 6 squared. And then 6 minus a negative 1. So plus 6 minus a negative 1 squared. And that should equal 7. Yep, the same as BC. So we have 113. Now, one thing we know is that we had a rectangle. So technically, if we were thinking a little bit ahead and not wanting to do so much work, I could have labeled AB as soon as I got it as 3 radical 2 and known that DC was 3 radical 2. Alright, but I kind of just went ahead and did both just to make sure that they turn out to be the same, because if we know it's a rectangle and I didn't get equal lengths on the opposite sides, then I know something in my math was wrong. But I wouldn't recommend that unless you had time at the end to go back and actually find the other 2 distances or other 2 lengths. So I also know I have AD is the square root of 113, and so is BC. So I know I have the rectangle they said I'll have, but now I'm not done because it asked me to find the perimeter. So now I have to add up those side lengths. And I want to leave it in exact form unless they say to find the decimal or something like that. So if we add up the lengths, we should have, let's see, in exact form, it would look something like 2 times the square root of 113 plus 6 radical 2. Now, if you wanted a decimal form and you hit the little squiggly or approximately symbol, that is about 29.75 if we round it to 2 decimal places. So either way, you never know what format the multiple choice options will be until you see them. So it could be written like that or like that. Either one should be your answer. Alright, so for number 13, we want to find the area of a rectangle with vertices E, F, G, H. Well, if we go ahead and draw basically a rough sketch of our rectangle, Here's our E, F, G, H, since it's going in that order. And if we want the area of a rectangle, we know the area of a rectangle formula is equal to the area equals little b times little h. So really we just need the base and the height, which is just one distance and then the other distance, the perpendicular distance. So to do that, we can simply just find two distances. We can find EH and we can find HG. Or you could have chose to do EF and FG, doesn't really matter, but as long as we are finding a vertical distance and a horizontal distance, we'll have both distances. So EH, if I just use E and H, label that as my x1, y1, x2, y2, I'll have the square root of x2, which is -3, minus my x1, which is minus a -4, plus my y's, so -4 minus 1 squared. Alright, that'll give me square root of 26, and then HG. So now if I label for HG, actually erase what I have here. So I have to label for HG, so we have x1, y1, x2, y2. So that's going to be the square root of, if I do the x's, -3. So x2 minus x1 would be -3 minus a -1. So -3 minus a -1 squared plus the quantity of -4 minus a -2. -4 minus a -2 squared. Make sure that goes over the whole thing, which that will equal 2 radical 2. So now if we're going to do A equals little b times h, we just found that HG is 2 radical 2. That's a 2. It's ugly 2, but it's a 2. And then our height, which is our EH here, is radical 26. So that goes here, radical 26. So we just have to do 2 radical 2 times radical 26. And in the calculator, you should get 4 times the square root of 13. So 4 radical 13, which if we needed the decimal form, it would be approximately 14.4. So we don't know what units we're in, so we could just say square units. Square units. Or you could also write it as units squared. Alright, so our final answer is either 4 radical 13 or approximately 14.4 units squared. Alright, so for the last two, same sort of thing where you're looking for either the area or perimeter from a grid. In this case, it's the area. So since we have what appears to be a rectangle or potentially a parallelogram, either way, however you see it, the area for either one is little b times h. So we need to find one distance and the other distance in the other direction. So we need to find both of those and then multiply them together. So if it's on a grid, I'm going to use a Pythagorean theorem. So if I make the triangle that is formed with the rise and the run for that side, it looks like it's 3 at the bottom there and 3 on the side. So if I use the Pythagorean theorem to find the length of DC, I'm going to have 3 squared plus 3 squared equals c squared, which that equals 9 plus 9, which is 18 equals c squared, which if we take the square root to find what c equals, c is just equal to 3 radical 2. So that's our DC. And then we also have to find CB. So now I'm going to do CB, and if I make the triangle for that one, that side there, let's see, I have 1, 2, 3, 4, 5, 6, 7. Side length of 7 there. 1, 2, 3, 4, 5, 6, 7, 8. an 8 there. So that's 8 squared plus 7 squared equals c squared, and that is equal to 113 equals c squared, so that CB is just equal to square root of 113. So we basically know that this side, DC, let's see, that is 3 radical 2. And then this side is a square root of 113. So to do the area, our little b times our h, we have to multiply them together. 113 square root of 113 times 3 radical 2. Now remember, since it's multiplication, you could have put the 3 radical 2 first and then the 113. Either way would have been fine. So if you do that in the calculator, square root of 113 times 3 radical 2. You get the exact answer of 3 times the square root of 226, which is approximately, if you change it to a decimal, 45.1 square units, or units squared. So either one of these are fine. It just depends on what form the answer's in. So I'm just going to put it on our answer line up here. 3 radical 226, which is approximately 45.1. Alright, so for the last one, number 15, you should notice it is a triangle. Remember we mentioned when you do a triangle, you know, what's the base, what's the height, etc. So we talked about that a little bit. So in order to determine what is the base, which side's the height, or if the height is in the middle, we first need to, we could see if we have a right triangle by looking at the slopes. Remember, if you have a right triangle, that means wherever you think the right angle is, those two sides must form a 90-degree angle, which means they must have perpendicular slopes. So for instance, I wouldn't think that this was a right angle. Definitely doesn't look like a right angle to me. I don't think this one's a right angle. It looks acute to me. But this one could be a 90-degree angle, so I am going to check that out, see if it actually is. So I'm going to find the rise and run from one point to the next. So 1, 2, rise first. Let's do that first. So let's go to B to C. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and I went down, so that's -9. And I'm running 1, 2, 3, 4, 5, 6 in the positive direction. So far that slope is -9 over 6. Now if I did the other side of where I think I have this right angle from this side, basically. I already did this one. So now I'm doing this one. So I am going from A to C. So I'd have to go down 1, 2, 3, 4. And then I'd have to run in the negative direction. So that's down 4, negative direction 1, 2, 3, 4, 5, 6. So that is to the left 6. So that would be a slope of -4, -6. So if I simplify these, I'm going to simplify because right now they don't look like opposite reciprocals to me. So let me just make sure. So this would simplify to -3 over 2. And this would simplify to +2 over 3. So if you simplify, you actually see you do have perpendicular slopes, or perpendicular lines. Therefore, you do have a 90-degree angle here. And remember, whenever you're doing the area of a triangle formula, the reason why I'm having to find where that 90-degree angle is because your little b and your little h are those two sides, are the lengths of those two sides where that 90-degree angle is. So the lengths we have to find for our little b and our little h is the length of CB and the length of AC. Alright, so to do that, I already have the triangles there, so I might as well use the Pythagorean theorem. So I have -9 squared plus 6 squared. Don't really need the parentheses if it's not negative. If it is a negative number, remember, if you don't put these parentheses on this -9, it will give you the wrong answer. So make sure you're doing that correctly. And that is going to equal our c squared. So if we solve that, we have 81 plus 36. 36 plus 81, which is 117. And remember, we have to take the square root. So CB is basically the square root of 117. And that, let's see, just simplify to 3 radical 13. So that's what CB is, which is our side here, 3 radical 13. So now we just have to do AC. And once again, we already have the Pythagorean theorem, their triangle there, so negative 6 squared plus negative 4 squared. You could just make them positives, because if you really understand, distance has to be positive. You don't need the negatives on the negative 6 and negative 4, but just to show it both ways, because some students forget to put those parentheses and they want to put the negatives there. So that's 36 plus 16, and that is 52. So this is going to be the square root of 52 in the end, because we'd have to take the square root. So that is going to simplify to 2 radical 13, which is now our AC. So 2 radical 13, which once again is our little a and our little b. So our area is going to equal 1/2 the quantity of little a and little b. Once again, you're multiplying, so it really doesn't matter the order in which you put those in, because multiplication could be in any order. And when you do that, let's see what we get. The whole thing equals 39. See, that is one reason why you cannot put these things as decimals and work with them. You should not round into the very end. So that's one reason why, because it could end up being a nice, pretty whole number, positive integer. I mean, we have the answer is 39. If you would have rounded or left this as a decimal here and this as a decimal here, you wouldn't have had exactly 39 in the end, because basically you rounded throughout the problem. So our final answer should be 39 square units, because we don't know if it's inches, centimeters, what it is. So that's our final answer. And yep, that's it. So hopefully I check your answers. Hopefully you got these correct and are ready for tomorrow. Make sure you practice the game online if you have not already, or if you just want additional practice, try it again. All right.